Hi, folks. So my talk is entitled, We Can All Be AI Engineers, and we can do it with open source models. And I'll talk about why that's important. So I just wanted to start by introducing myself. I was told to do this last time I did a talk, and it doesn't come that naturally to me to try and big myself up, but I'm the CEO at HelixML. I also run a company called MLOps Consulting, where we help companies with MLOps. That's all turned into GenAI these days. I also started a thing called the MLOps community, which is a Slack community that's now got over 20,000 people on it. So if you're interested in MLOps, LLMOps, it's a great place to be. I'm also a startup guy, so this is my third startup. I previously did a startup in DevOps, which was called Cluster HQ, and then an end-to-end MLOps platform called .science. So my career has kind of been DevOps, MLOps, and now GenAI, which hopefully puts me in a useful place to be able to explain some of this stuff. So what I want to argue in this talk is that we can all be AI engineers now. The tooling is now good enough that it's possible for everyone to do this. It used to just be the domain of data scientists and people writing pages and pages and pages of Python. But now it's possible to do it with much simpler tools. And also, if you have basic technical skills, which I'm sure most people in this room do, right? Because this is the developer experience track. Like if you're comfortable with an IDE and writing YAML files and pushing them to GitHub and doing pull requests, then you can also make a GenAI application production ready. And so I'm actually going to show this to you. But first, I'm going to just share a little bit of background information about the different pieces that we're going to see, and then I'm going to really show you how you can actually do it. So if we're talking about building a GenAI application, the first step is always prototyping. And like I said, this is the part that anyone can do, because you can just do it with a web browser these days. So you can prototype a GenAI application by picking a model, like which model do you want. There's some really good open source models. The space has come on really quickly in terms of open source models, and the latest models from Meta, like Llama 3.1, super good. Then you can write prompts, and I'll talk about what that means. You can then plug in knowledge, and you can plug in integrations. And you can do this quickly, like I said, in a web interface. And then we can take that prototype of a GenAI application, and we can get it production ready. So we can actually get it to be usable by real customers, real internal users, whatever your use case is. And how do we make GenAI applications production ready? Well, funnily enough, it's the same way that we do with software. It's just tests and deployment. So it's CI and CD, basically, continuous integration and continuous delivery. And what testing and deployment means for GenAI apps is slightly different, and I'll talk about that. But fundamentally, we're just going to make our applications production ready in the same way we always have done, by using version-controlled YAML files in Git, basically, the same way that we do with software. So I'm going to talk through these kind of building blocks that I've already touched on briefly, and go into a little bit more detail on each of them. And then I'm going to try and leave enough time for a demo that I only just got working, so I hope I have enough time to squeeze it into the talk. So the building blocks are models, prompts, knowledge, integrations, tests, and deployment. Those are the things I've already mentioned, but let's go through them. So models, these large language models that everyone's here to talk about, are just mathematical models. They are just big, very complicated, multi-dimensional functions that take some input, which are numbers, like words turned into numbers, and read off an output, which is a sentence, which is the answer. And that's fundamentally all that these LLMs are. So you can just think of them as like really fancy models. And I'm not going to go into all the maths, but they are just mathematical models. What are the prompts? The prompts are the things that you feed in as the input to these mathematical models. And you just literally tell the model what to do in natural language. So for example, one of the prompts that we're going to look at later in the demo is present the key information in a concise manner, and then we're going to add and perform any actions requested by the user. But if you imagine that the prompt didn't say and perform any actions requested by the user, you'd see that the model might just present the key information. I guess I'm kind of giving away the demo a little bit here, but that's an example of like how it's important to tell the model actually what you want it to do. Knowledge is just this idea of giving the model knowledge, facts that it can search and refer to in the answers that it gives you. And the way that this works, and I'm sure people have heard the phrase RAG bandied around, which I think is an unnecessarily complicated term. I prefer knowledge. But RAG just means retrieval augmented generation, which means you get some information, you augment the prompt with it, and then you do the generation. And so I'll give you a concrete example to explain what we're seeing here. We have a vector database where we can put documents, basically bits of text, and then we can get responses out of that vector database, and then we can put the prompt plus the response into the model to get a result. That might sound confusing. I'll illustrate it with a concrete example. So back when I made the first version of this slide, back in July, what was in the news? It was Kamala Harris raising $50 million in 24 hours. So what I did was I took all of the news articles on the BBC that day and I put them into the vector database. And then I asked the vector database, how much did Harris raise? And it's basically just a search engine. And it returns back this concrete example, like the actual response. And then what we do is we feed the question and the context together into the model. And then the model gives you a good answer, which is correct. And it's correct because it's grounded in truth. It's grounded in the facts that it got from the BBC News website that day. So that's knowledge. Integrations is just allowing the model to call APIs on behalf of the user. So obviously, APIs are how all business systems work, and you can connect them together. So the idea here is that you have a prompt, which is saying maybe like, what laptops are in stock? If you have a product catalog that you're integrating with. And then there's this process that happens when you use this API integration, which is classify, prepare, and summarize. So you start by classifying, does the user's request require an API call at all? Because if the user's just asking what's the capital of France, then you don't need to go and look in the product catalog, do you? So you decide whether you're going to make an API call. Then if you decide that you are, then you prepare the API call. So you prepare the request body or the query parameters. And then you make the API call and you summarize the response back to the user. And so what we'll see here is very natural seeming interactions with LLMs, where the LLMs are actually making API calls behind the scenes on behalf of the user. Now we have tests. So thank you, Phil, for writing this example yesterday. This is some simple tests that you can put together, which is how do you know if this system that you're building with knowledge, with integrations, with prompting, is actually doing the right thing? And it's in exactly the same way that you would test software with these sort of unit-style tests that have an expected output, and then you compare the expected output to the actual output. But in this case, you additionally need to have an LLM also act as a judge, because the answers, the responses from the LLM aren't always going to be exactly the same. So how do you even know whether it's giving you the right answer? And the way you do that is by having another LLM pass or fail the result of the test. And so I'll give you a concrete example here. So you might have a developer here on her laptop who is updating the code or updating the configuration of one of these apps. Remember, these are all the different pieces of AI apps when we're building them. And some of that configuration is model, prompt, knowledge, API integrations, and tests, and so on. And what we're capturing those in, by the way, the title of this talk is about the AI spec, and I'll talk about that in a minute. But the point of the AI spec is just capture all of these aspects of building applications in a YAML file so that you can version control it, like we always do. So what happens here is the developer, she pushes a change to her branch to maybe add a new feature to this chatbot, and then the CI system, so for example here GitHub Actions, would run a command to execute those tests in the spec. And if the tests all pass, then she's good to go ahead and merge the pull request to main. And the way that this works under the hood, in what I'll show you, is that it will actually spin up the AI spec app. It tests it, and like I said, it uses another LLM to evaluate whether the answer is good or not. And then deployment, well, that just means run it on a server. And I won't go into all the details about how you do that, but with Helix, you can spin it up very easily. There's a one-line install and so on. It's free to try, so it makes it easy to run these open source models locally. But what you can have here is that the user, the developer, she merges that pull request, and then, well, how do we normally deploy things to production when they land in main? Well, there's a couple of different ways of doing that. The very simplest one is basically just run Helix apply inside the CI system. So every time something hits main, you deploy the latest version of that thing to production. And then you have a happy user because their application has got better because we've iterated on it. We've tested that it works. We've checked that there are no regressions. This is just normal software development process. But you can do it with GenAI, and it is possible for everyone to do that. So that's kind of my takeaway here is it's not that complicated to do these things. It's accessible to everyone. And so I'll show you how we can do that. So the first thing I'll do is I will show an example of building an AI application. And I promised to begin with that it was easy for anyone to do just with a web browser. So let's build an AI application for this conference. Let's call it AI for the rest of us. I'm going to hit save here. You can put in a description. You can give the model a prompt, which is these instructions on how to behave, talk about the conference, and then we can add some knowledge to the conference. So, add some knowledge to the app. So let's go ahead and put in the website URL. So that will then go and scrape the contents of the website. You can see we can specify don't follow links to more than a depth of 1, only index 5 pages, which is sort of good defaults. But if you've got a bigger website, you can scrape more of it. And then I can show you. Remember, we had this sort of vector store piece. Let me find that diagram. This pink piece is the vector store. So we can start out by just like checking. We can query the vector store directly without going via the language model. And we can say conference. And it will find results. And you can see they've been chunked down into these little chunks of markdown that can be included along with the prompt. And so you can now say, tell me about the conference. And it will go and talk about the conference, which is correct. It even talks about you, Matt. So that's like step one. We can prototype an app in the browser. And look, the output of prototyping the app is this YAML file, right? The YAML file is the AI spec. That's the thing that we can then take. So any business user can prototype an app, and then we can go and turn that with a DevOps team into an application that's production ready. So the next part of the demo I want to show you is how you can do that productionization piece. So I'm going to show you a demo that, or an application that I'm actually building for real for a customer. So let me just grab this. So this is an integration with Jira. I'm sure everyone is familiar with Jira. Is anyone not familiar with Jira? All right, good. So this company uses Jira, and what we're doing is we're building a natural language interface to Jira. So we can see we've got some sprints, we've got some issues in the sprint. This is all fictional, it's not a real sprint. And one of the issues in the sprint is to build a tic-tac-toe game in React for a front-end application. So what we're going to do is we're going to start by checking if the app is actually any good at doing that yet, right? So we're going to say implement the code for issue DS9. And then we can see. well, that's no good. It's told me about the issue, but it hasn't actually implemented the code. So we're good test-driven development engineers. Let's write a failing test that demonstrates that the system is not yet capable of writing code for an issue. And so you can actually see, hopefully it's legible here. I'll zoom in a little bit more, the risk of not having any space left on the screen. You can actually see this is the AI spec for this application, which you can also edit through the web interface. It has an open API spec built into it, which is a Swagger spec, which is how the LLM knows how to call the Jira API. We've also taught the model how to speak the Jira query language, because it didn't know before. So we taught it by giving it some examples, because that's how you teach LLMs things. You give them examples. So we said, like, oh, if you want to be able to get all issues assigned to me, then use this JQL. And that actually works, because then the LLM will go and query the API with correct JQL when it was getting it wrong before. But let's write a failing test. So what branch am I in? Oh, I can't see. I'm in main. OK. I'm always paranoid. I always pull before I do anything, which I think is probably sensible. So I'm going to make a new feature branch called writing code demo. And then I'm going to go in, and then I'm kind of cheating here because I tested this before. But what I'm going to do is I'm going to write a failing test that captures that same issue that I just experienced when I tried to use the LLM myself. So the test is just the user asks, write some code for issue DS9, and the expected output is a code snippet that fixes or implements the tic-tac-toe game. So let's, actually, before we push any code, let's just run Helix test. And so what that's going to do is it's going to run through all of the tests in the YAML file, and it's going to execute each of them against production. And you can see there's a little F down there, which is promising, because we've got one of our tests that's failing, and hopefully it's the one that we just wrote. So give that a second to run, and then it loads up this report in the browser. And yes, wonderful. We've actually got a failing test in our test report. And what's more, we can click a button in here to see the actual interaction that the user had. Let me make this a bit bigger. And indeed, the test is just exhibiting the same bug that I had earlier, which was that it was refusing to write code, even though the user explicitly asked for code to be written. So let's go and debug that. Like, why did the LLM refuse to do that? Well, let's go in and we can actually look at all of the interactions between the system and the language model. And if we look at, for example, I think it's the last one. Remember I said it was classify, prepare, and then summarize? I think that's the is actionable step, the prepare step, and interpret response. That's how these API integrations work. And it's going to be the interpret response where the language model would have had to actually write the code. So if we look at what the language model was asked to do, it was just asked to present the key information in a concise manner. So it didn't write the code because its system prompt told it just present the key information. And then it was given the API response. This is the actual raw API response from Jira. And then what did it do? Well, it just went and summarized the information. It literally did what it was told. So there's no wonder that the chatbot isn't doing what the user expects. So let's go and change the prompting for this system. What we can do is we can, and I'll do a commit, by the way, because when I'm doing test-driven development, I really like to have a commit that shows failing test and a little cross, and then another commit that says passing test. Yay, I made the test pass. Let me just go here, and we can see this is, let's make a pull request for writing code. And so we're going to push that, well, we've opened the pull request, and yep, so that's kicked off the test run. And you can see that this CI for GenAI test is running. If we go into GitHub Actions, we can see it's running the same thing that I ran locally when I ran Helix test in CI. Actually, while we're waiting for that, I can show you the GitHub workflow for this. I was thinking to myself this morning as I was on the train, like, this is where I get to prance around on stage showing YAML files again, because I did that previously in a past life. So it's all about the YAML. So what we have here, we have two jobs. The first one is if we open a pull request, then we run Helix test, and then we post the result of that summary markdown file onto the pull request so that we can see the issue. And then the second one is if we're actually deploying to production, then what do? Well, we just run Helix apply if the tests pass. And that deploys the application to production. So we can actually do real CI/CD for GenAI like this. And it always scares me when I see a red, but that's actually intended because this is meant to be a failing test. Yeah, if we come here, we can see that indeed the test is failing. And we can see those same links to looking at the debug information, for example, and understand why it was failing. So let's try and make the test pass. Again, I'm cheating because I figured out how to do this earlier, but the key here is that you need to tell the LLM what you want it to do. Like, if it's not working properly, it's probably because you didn't tell it what you want. And so what we can do is, instead of saying present the key information in a concise manner, we can say present the key information in a concise manner and perform any actions requested by the user, such as writing code. And then just to be extra safe and certain, I'm going to be really clear with the LLM. If the user asks you to write some code, you must write the code. Start by describing the task described and then write the code. So it's like, okay, I'm kind of explaining in a slightly patronizing way to my language model that I really want it to do that. It's a bit like talking to my 3-year-old. Now we can do Helix test, and we can see if that works, and hopefully that will cause the tests to pass. And then we can deploy the change to production, and then we'll have a better application than we did before, because now we have one that can interact with Jira, write code on behalf of the user, and yay, it worked. Okay, so I'm going to do a commit, passing test, push that, and now we're just waiting for CI, and that's running. So yeah, let's have a look at what's going on inside here and recap. So it's installing the Helix CLI. It's running the test. The way that works is that we have applications inside here that are scoped to the test run. Because what you don't want to do is you don't want to deploy the application to production in order to test it. So what we do there is we just generate a random test run ID and prefix the application name with that sort of namespace. It's like a cheap namespace. And yeah, then we can see that passed. And then we can merge the pull request. There we go, we've got the test summary. Then the application is going to hopefully write code for us when we ask it to. It's just going to run for a few seconds first. So yes, we use those namespaces to isolate the test runs from the rest of the system. And that way, every time you push code to a branch or you run a test locally, then it's always just going to make sure that it's not interfering with the production deployment of the application until that deployment hits main, and then it's actually going to deploy it, as you can see here. So it's deployed the application to production. And now if we ask it, please write code for issue DS9, and cross our fingers, we can see that it's searching the Jira issues. And it does it. We can see it's actually generating some code to play tic-tac-toe in React. So yeah, that's the demo. I'm honestly quite relieved it worked, because we just got it working. And yeah, the last point I want to make, and then I'll wrap up, is that why do we use open source models? Why do we care about using open source models rather than just building everything on top of OpenAI or Anthropic or something else? We care about using open source models so that your data doesn't leak outside of your organization, and so that you can apply AI to use cases that are more sensitive. There's many companies in Europe especially, and all over the world, who, for whatever reason, can't send data outside their own country, or want to make sure they're GDPR compliant, of course. And so being able to run local models in your own, for example, your own Azure zone, like Matt does, is super important. And it makes sure that your data that you're sending to the LLM doesn't end up being someone else's training data. And the AI spec that I talked about in the title of this talk is simply a way to, it's a proposal for a standard way to capture all of these things I've talked about, where you can specify the system prompt, you can integrate with APIs, you can do knowledge, and then you can also do testing on the result. And you can capture that all in the same artifact. So thank you, that's me. There's a few things I want to shout out just really quickly. The first one is we're running a workshop tomorrow at 1:20 in the London Wall Room. So please come along to that. It's in the second half of lunch, so feel free to bring your lunch in there, and we'll all deploy some local models together. The goal for the workshop is to actually deploy what I showed you on your own laptop. So check that out. If you look at the blog post, blog.helix.ml/p/workshop, there's a list of requirements. You can download some stuff before the workshop to make sure that it runs nice and quickly. If you can't be bothered to come along tomorrow at lunchtime, then you can sign up for online workshops that we run as well to help people get started with local models. Join our Discord, and that's my QR code for LinkedIn. So I'd love to connect with you. Thanks very much.